So we're going to go over all of those factoring, the two factoring problems and the synthetic division problem from the homework worksheet 8A. Okay? So factor number 17. We have two terms and we have a minus in between. You know, guys, the first step in factoring is always GCF, right? So what I'm going to do is I'm going to go in the calculator and do that GCB thing, right? And see if 25 and 49 have a GCF that I can take out. So let's do that. 25, comma 49. Do you remember where that is? Math, number, GCD. And remember, your calculator can't do negatives, and they can only do 2 at a time. So 25, comma 49, 1. So that means I can't bring out anything. I don't want to take out a 1. It's not going to change the problem, right? So 2 terms still. Now I have 2 different options. Is it a dose or is it a soap? Right? So the 2 ways that you can factor further when you have 2 terms. So dose means you have to have a subtractant between them, and everything has to be a perfect square. Right? Like I can take the square root. Turn your sound off, okay? But so it could be a plus or a minus, and they all have to be perfect cubes. Okay? All right, so let's look at this first one here. 25x to the 8th minus, okay, what's the square root of 25? 5. What's the square root of 49? Is that a perfect square? Do square root of 49? Okay, we're going to take your calculator out. 7. Okay. So, look at your variables. X to the 8th. Remember, I told you, you can take the square root if you can divide it by 2 and it gives you a nice pretty number, right? You could divide the exponent by 2. What's 8 divided by 2? Yeah, then that tells me I can take the square root. This is a perfect square. And then it becomes x to the 4th. So what about the y? Yeah. And then if I have y squared, well, I can take the square root of y squared, because like that, you could also divide that by 2. That gives you just y, or a y to the 1st, right? Do you agree? So this is a dose situation, because look at that, they're all perfect squares. And remember, dose is double parentheses, opposite signs, and the first term goes in the first one, 5x to the 4th. Second term goes in the second one, 7y. And there you go. I can't dose it anymore, I can't soap it anymore, so I'm done here. Are we okay with that? Alright, good. Alright, so this next one, you know, now we have a trinomial situation, yes? AM. Well, I still need to see if there's a GCF for the whole thing. But if I look, I have 1, 11, and 60. Anytime you have a 1, GCF is always 1, right, Abner? Okay. So I'm going to go straight into my AM situation. So that means I need to draw a T-chart. So I need 2 numbers that multiply to give me what? What's my M number? Huh? Negative 60. And what's my A number? 11. Good. All right. So what are 2 numbers that multiply to give me negative 60 but adds to give me a positive 11? All right, remember there's that trick in the calculator. You go to y equals and you put in your n number divided by x. So let me show you. Negative 60 divided by x. Right? You remembering this? You're coming back? Tom, coming back? Second graph. And then if I look, on your table, it gives you a list of numbers. What you're doing is you're going to add those two numbers and see which one gives you your A number. So we want 11, right? Negative 4 plus 15. Well, there we go. That's no fun. First one works, right? Negative 4 plus 15 gives me 11. But like say I looked here, negative 1 plus 60, well then that's 59. I know, oh, nope, that one's not good, right? We don't use decimals and we don't use the error. All right, so we have our number here, negative 4 and 15, which adds to give me 11. Do you agree? So let's get to factoring. Bring down the first, bring down the last from your original here. And then you want to rewrite your middle term using the two numbers that you found. And remember your middle term is x squared. So negative 4x squared plus 15x squared. Okay? So now you have 1, 2, 3, 4 terms. What do you do when you have 4 terms, guys? How do you factor this? Yeah, divide it in half. Good. And then you're going to GCF both sides. So if you look on the left-hand side, you have x to the 4th minus 4x squared. What do they both have? X. So which x comes out? X to the 4th or x squared? Squared. It's always the smaller exponent that comes out. Okay? Oh my god, did I write it there? And then I asked?
I thought you based on whether you can take it out the other one.
You can, and which is always going to be the smaller one. Oh my gosh, so I wrote it there and then I asked. Sorry, guys. Alright, there we go. Just so, like, have it, you know? Alright, so x to the 4th divided by x squared. Remember this? Means we have 4 x's on the top, and then we have 2 on the bottom. How many are left? 2, because those cancel, right? X squared. Minus, what happens here? What's negative 4x squared divided by x squared? 4. Okay? And then 15x squared minus 60. Guys, can I take an x out on the right-hand side? No, because the negative 60 does not have an x. However, 15 and 60, I know they have a GCF. What is it? Good. It's 15. Divided by 15. So we have x squared minus, what's 60 divided by 15? Huh? 4. So Kevin, how do I know if I'm doing this right? Good. If your parentheses are the same, and they are here. Good. So I know I'm doing this right. So now I'm going to go to my double parentheses. I'm going to put in x squared minus 4, and then x squared plus 15. So technically I'm done factoring that trinomial, but am I done factoring the whole thing? No. Abner, what do I need to do? Good. Which one? The minus or the plus? Good. Yep. So x squared minus 4, this could be dose. Oh, I know. That's not dose. No? Huh? No, is that right? Can I say it that way? What's the square root of x squared? What's the square root of 4? Listen, you guys are gonna have to teach me some Spanish. We're gonna get this going. And then please don't forget to bring down your x squared plus 15. Okay? And that's it. Now you're all done because you can't factor anymore. Okay? Alright. ¿Está bien? No? Is that right? Did I say that right? Alright, so synthetic division. Alright, so with synthetic division, we have this polynomial divided by x minus 1. Well, if they give you a factor, remember, I want the 0, right? So then this, I need to change it to x equals what? 1. Good. And if they just gave you a 0, then use that. You don't have to change it if it doesn't look like a factor, okay? So then the 1 goes here on the outside. I know that, right? Now I'm going to look at this guy. All right, you got to make sure that you have your biggest exponent first, and you go down a degree. You fill in for all of the missing terms, right, Tom? Focus, watch this, okay? So, x to the 4th, that one's my biggest exponent, right? So I start with that. What is 1 below 4? 3. Do I have an x to the 3rd? No, so I need to put 0, x to the 3rd. What comes after x to the 3rd? Oh, x squared. Good. What comes after x squared? X. X. Right? Do I have an x term?
Yeah.
No. No. Look, there's no x. So I have to put 0x. What comes after the x? Yeah, your constant. The one that doesn't have any variables to it, it's just a number. You have to have that one too, okay? And if I didn't have a constant, I would put 0 for it, all right? So then now what we're doing is we're basically taking all of the coefficients and we're bringing them down, okay? So 1 for that x to the 4th, then a 0, then a 12, then a 0, then negative 13, yeah? So we did this before the break. First one always comes down, straight down. And then diagonally, what do they do? Anyone remember? Multiply times, What's 1 times 1? What do you do when you go straight down? Add it. What's 0 plus 1? And then multiply again. What's 1 times 1? And then you add straight down. What's 12 plus 1? 1 times 13. Add 1 times 13. And then add 0. Good. So, you know, they said to actually divide. I can't stop here because this actually makes no sense. I need to make sense of it, right? I'm gonna put my little dotted lines here. R, C. What comes after C? Remainder, and then the constant, and then what's after constant? X. You're going backwards. What comes after X? X squared. And then what comes after X squared? Good. Alright? So then now, just rewrite it. It's 1x cubed, so just x cubed is fine. Positive 1x squared, so plus x squared. Positive 13, so 13x. Positive 13, so plus 13. And there you go. Okay? So guys, here, what if they said, is x minus 1 a factor of this polynomial? What would you say? Yes or no? Yes? Why, Sabrina? Good. Yep. Yes, if your remainder equals 0. And obviously, this question didn't ask you a yes/no type of question, but if it did, that's what you would say. All right? All right, so just to pick up from where we left off last time, we're going to talk about whether it's continuous or one-to-one. So with these, guys, they give you the functions, and they actually want you to graph it. So let's do that. Let's graph this. Easiest way to do it, just put it in the calculator, okay? Put in the calculator, go get your table, plot your points. There you go, boom, right? X minus 2. All right, that's cubed. If yours looks like mine and it just does that, then it's fine. You can just do +1. If your calculator makes that 3 jump up, make sure you hit the right arrow so that it comes back down, and then you put +1, okay? Or else you're going to be putting a +1 in the exponent. You should try it. Your calculator's fancy. All right, graph it. Oh, if your screen looks weird like mine, just go to Zoom 6. Zoom standard. It'll take you right back, okay? All right, that's what it looks like. Let's go and get some points. You know, the only points that I can actually really graph are from 0, -7 to maybe 4, 9. You know, and that's stretching it a bit. So, okay, let's do that one. 0, -7, 1, 0, 2, 1, 3, 2. Say 4, 9 is about there. Yeah? Eyeball that one a little bit. Oh, I love it. This is that cubic function snake, right? Now, is this continuous? Guys, do you see any gaps or holes or breaks in this graph? No. So you know what? It's continuous because we don't have any breaks. Just continues on. We can trace it with our finger without picking up our finger, right? Now, is this one-to-one? Yes. Good. If I do the horizontal line test, does it hit the graph at only one spot? Yes. Okay. These kind of graphs, they are continuous and they are one-to-one. All right. And if I were you, I would put a star on this because you may see this again.
Wow.
Yeah, I know. Number 2. It's an absurd equation. But you know what? Thank goodness we have our calculators. Let's go and graph it and see what this guy looks like. Please make sure that this negative in the front is an actual negative and that you didn't use subtract. If you use subtract, you might get something else, okay? So if I graph this, let's see what we get. Huh? You did not get this?
We got 2 vertical lines.
Okay, so go back and make sure that you copy the problem. We're all here, right? So I see that we have a couple of turns and things. You know, we're going to eyeball those, okay? So the easiest thing to do, I think, is to go and get all your zeros, right? We have one at 1, 2, and what, 5? Let's go to our table. Let's check. Oh, yeah. Right? So I'm going to bring my points over. There we go. And really, the only points I can actually use here, 1, 0 to maybe 5, 0, right? So let's graph those. looks like my first turn goes up to 1, 2, 3, right? And that's between the 1 and 2. All right, so you do that. Maybe something like that first, right? I'm not going to make you find the exact maximums and minimums right now because we're just concerned about the continuous and one-to-one. So then, yeah, let's just do this. Okay, bless you. All right, are we okay with that? Now, is this continuous? Kevin saying yes. Confirm? Hmm? You don't know? Okay, so if I use my pencil or my marker here and I want to trace this graph, can I do it without picking up the pen? Yeah. So it's continuous. Okay. You want me to show you an example of what's not continuous? Do you think that might help? Okay. So if I have a graph that looks like that, okay? That is not continuous. Okay? Because I can start tracing, but I have to pick up my pencil to trace the rest of it. You see what I'm doing? Okay? So that is not continuous. But one-to-one, Tom said, no, this is not one-to-one. Why?
Said 4 points.
Yeah, at one point it does touch it at 4 places. 1, 2, 3, 4, right? If I run a horizontal line through this, I only wanted to touch it at one spot. So no, this is not one-to-one. Good. All right. Now let's talk about the domain and range. Okay, so domain is talking about the x's or the x values of the function, right? We know this. You look from the left to the right. Here's the good part, guys. Put a star on this. Polynomials have domains of all real numbers. Okay, so that one, always. All right. Range is the what? Which values? If domain is x's, range is
Y.
y's. Good, the y values, right? And you basically look from the bottom up to the top. So, let's talk about the domain for the first one. What is the domain? What I say, always. Yeah, but what is the domain for polynomials, guys? Yeah. Now, let's talk about the range. You know, I know there aren't arrows here, but there are supposed to be arrows. With the range, you're basically looking for arrows. If you see an arrow going down, it's going down to negative infinity. If you see an arrow going up, it's going up to positive infinity. Okay? So, this one. You have an arrow going down. Where's it going? Negative infinity. Okay? And then now, I'm going up. You see how it overlaps here? That's okay. All right? Because it means that, you know, they're all still hitting that same negative 2, negative 2, negative 2. Okay? So we keep going. The graph never stopped. So technically, it's going all the way from this to what? Arrow up. Where's it going? Infinity, right? You have an arrow going down, you have an arrow going up. There's no break in the middle, so even if they overlap because they curve, it's okay. All right? Still going from negative infinity to infinity. Now, let's talk about the real zeros. Real zeros means the x-intercepts. I have 3 here. What are they? Or where are they? And we can put it in a little solution set. Where are the zeros? Okay, -2, 0. So I'll just put -2. What's the next one? 6, 0. Just switch on, right? But I'll put 6. And you don't have to put the 0. Just put x equals and then put them in the solution set. Okay? All right. And what's this one here? 1. All right. Are you gonna write this down? You're not writing this down. All right. So let's look at the next one. What is the domain? Yeah, got it. Always. The domain always. For your polynomials. Now, let's talk about the range for this guy. Do you see an arrow going down? No. So this means that we're not going all the way down to negative infinity. We got to see where this graph starts. I'm sorry, Tom? Good. It only goes down to right here, -9. Good. And that -9, it has a closed circle. So what notation does it get? Good. Bracket. And then we keep going up, up, up. And we have arrows going up. So up to where? Infinity. And then parentheses, okay? Because remember, the infinities always get parentheses. All right? Now, let's talk about the real zeros here. I have one there, got another one there, and another one here, right? So where are my zeros? Where are they? What numbers? -3, 1, and 4. So tell me something. One of these is special. Which one? 1. Why? You know, it is in the middle, but what does this one do that the other ones are not doing? How does it look different? Huh? Okay, it's a maximum, so it means that it turns right there. Yeah? So if here's my x-axis, right? I have one that goes through the x. Yeah? I have another one that goes through the x. Okay? But how come this one, wait a second, what did that one do? It bounced off. It turned there, right? So anytime that it bounces off there, it means you have 2 of them. Okay? You have 2 at that number. So with this guy, with the 1, I'm going to put times 2, or I'm going to put double root. Right? So double root. Questions? All right. Are we okay so far? See you guys writing down. Busy. So now we're going to talk about finding the local maximums and the local minimums. All right. So the local minimums are basically, the local maximums. It's up at the top. It's basically at the top of the terms. All right. You're not going to write anything down. You're not even on the same page with us. Local minimums are at the bottom of the terms, right? Because they're the minimum, right? Do you not have it? Why? Where's the packet? You split up the packet? Okay, so let's look at this. Yeah, the local maxes and the local mins. Guys, with this, we want the ordered pair. I actually want like the ordered pair for this, okay? Because if you tell me the point, I can go and grab it. All right? So, local maximums. Well, you know what? There's one right here. And local minimum, well, there's one right there. Yeah? What are the points? What is that maximum point? Or local maximum? What is the point for this local maximum? Yep. -1, 3. How about the local minimum? Good. 4, -7. Perfect. That's it. That's all I want you to do with that. Can we go and find the local maximum and the local minimum for the next one? And you know, you're not using any U's or anything like that here, okay? Just use commas to separate your ordered pairs because you're just telling me points, all right? So I have one maximum, which is 1, 0. And then my minimums, I have 2. Yeah? So you have? Okay, good. All right, so there's a practice problem here. It says find the local maximums and local minimums of this function. All right, so we're going to put this into the calculator, and you know what? We may have to use blinking Bob, okay? But here's the thing. How many can there be? You guys know the rule for finding the maximum number of turns, right? What is your biggest exponent here for this guy? Huh? 4. Number of turns is 4 minus what? 1, which equals 3. So we may have 3 turns here. All right, let's go put it in the calculator and let's see what we get. All right, so I'm going to put this in the calculator. I'm going to graph it, see what that looks like. Okay, looks like this, right? If you want to, you can zoom in. Do you want to zoom in? No? Sorry? Okay. Hmm? I know you can, or, you know, everyone said no, it's fine. Okay. So let's talk about this then. Looks like I have, yep, I have a maximum, a local maximum here, a local maximum there, and it looks like I have a local minimum right here. That local minimum looks like it's at 0, 0, right? All right, well, let's make sure, okay? Let's go use Blinking Bob, and then we're going to find each of these starting from the left. So let's start with this first maximum, okay? All right, so I'm going to go to second trace, right? And the first one we're going to look for, we said, is a maximum, right? So I'm going to go to maximum. And remember, with Blinking Bob, you want to take Blinking Bob to the thing that you want. So this maximum, right? That's my starting point. And then if you look, the calculator's saying go to the left. So I'm going to hit the left arrow. 1, 2. I guess I only need to do 2. I could do 3, right? now I'm going to hit enter. Now, I'm going to go back to the thing, like the starting point, right? And then now my calculator is saying go to the right. Hit the right arrow. All right. 1, 2, 3. Hit enter. Yes? And then when it says guess, just hit enter again. And there you go. There's my maximum. Yeah? All right, there's one maximum. Let's write this one down. I have a negative 0.69 and 0.40. If I round to the nearest hundred, right? Just going to delete that out of there for now because I don't want to. Okay, so now let's look for this minimum. Yeah, it's the same thing. I can hit graph so I can clear everything. I'm going to go to second trace minimum. Now move your blinking bob to that minimum. It's right there. It says 0, 0, but I'm just going to make sure. And now it says go to the left. So hit the left arrow. 1, 2, 3. Hit enter. Go back to your starting point. And then now your calculator is saying go to the right. So hit the right arrow. 1, 2, 3. Hit enter. When it says guess, hit enter again. Weird. What does it mean when I get these E's here when I do blinking bob stuff? It is a scientific notation, right? But you know what? Anytime you get these E's when you use blinking bob, it's 0. Okay? So your X number, there's an E, that's a 0. Y, 0. Yes? So we were right. This minimum is 0, 0.
Why doesn't it say 0, 0 on there?
You know what it is? They just get so exact, you know? Because technically, this is 1.0324 times 10 to the negative 6. And if you guys remember scientific notation, you're taking that decimal and you're going to the left 6, right? So then you have 0.00000010. You know what I mean? Basically 0. Yeah, it's like with the whole, yeah, we do scientific notation and significant figures. All right. So now let's go find that next maximum. So second trace maximum. I'm going to take blinking bob over to that maximum. Calculator says go to the left. 1, 2, 3. Hit enter. Go back. Calculator says go to the right. 1, 2, 3. Hit enter. Says guess. Hit enter again. And here's your maximum for this one. 1.44, comma 2.83. Yes? So that was just a little review on using blinking bob, right? We've used blinking bob in the past. All right, so now let's talk about increasing and decreasing intervals, okay? So your increasing and decreasing intervals are split basically by your turning points. Anywhere you have a turn, that means your maximums and your minimums, okay? Your local max mins, for the most part. I guess we could just say max mins. Sorry about that. Okay. All right. So what you're gonna do is 1. You're gonna find the turning points, maxes and mins. Now here's a use a different color. Here's a local max right there, and there's a local min right there. Yeah? Where is it? Where is that local maximum? What point? That's 0. Here's 0. negative 1, 3, right? So your local max is at negative 1, 3. Where's your local min?
Negative 4, negative 5.
Negative 4, negative 5 would be
Other
here.
one. 4 negative.
4, negative 5 is here.
No. 4 negative 7.
Good. 4, negative 7. Okay? I think it sometimes helps to see where that point is, right? All right, and then now what we're going to do is we're going to label on the graph where it's increasing and decreasing, okay? So, guys, with this, all right, you're always going to have a negative infinity on the left, and you're always going to have a positive infinity on the right, okay? Now what you need to do is you need to draw a vertical line through your term. Okay? But tell me what number, what x number does this line cut through? Huh? What x number? Negative 1. Right? So negative 1. Now this other one, the local min, I'm going to draw a line through that local min, and then we're going to see what x number this line goes through. 4, right? And then from here, we can do our increasing and decreasing. So from the left to the right, what is this graph doing from negative infinity to negative 1? It's going what? Up. Decreasing. Good. What is this doing from negative 1 to 4? Decreasing. And what's it doing from 4 to infinity? Increasing. Okay? And remember, with increasing and decreasing intervals, we always use parentheses, and we always use U's to join our intervals together, right? So let's make a little note for ourselves. Always parentheses. All right, increasing. And then from 4 to infinity. All I'm doing is just copying those intervals, right? Decreasing is only between negative 1 to 4, right? Questions about this? I know it's a lot of information, guys. Graphing, right? It's just a lot. All right. So let's try this. Let's practice this. Okay. Before we go and practice, I want to do this one with you. The cubic function, the one that looks like a snake. All right. Put a little star on this because this one is a little bit, it can look a little bit weird. So with this cubic function or this little snake looking function, you know that this has arrows. Okay. Now, do you see a clear local max or a local min here? Do you see any clear like turns with the hills? And no, right? Because this doesn't. This actually doesn't have a maximum or a minimum. Okay? So basically, you know, we always have a negative infinity and we always have an infinity, right? With these guys, these cubic functions, you're either going to have the whole thing increasing or the whole thing decreasing, okay? Always with this one. Does that make sense? So what is this one doing from negative infinity to infinity? What is this one doing from the left to the right? Huh? Going up, increasing. It's increasing the whole way, okay? And there is no decreasing. All right? So So for this other one, you know, I'm going to put a little point at all of the turns. And I know we have negative infinity all the way to infinity. I want you guys to try this one, and then we'll compare it. Alright, so with this one, let's check our numbers together. Negative infinity, negative 2, 1, 3, infinity. Yeah? It's your hand raised. You have a question? What's your question?
Isn't so both those number options and one goes negative 10 and one goes
Yeah, because we're talking about the x numbers, right? If you keep going to the left, you're going to negative infinity. Yeah, there's 2 for increasing and there's 2 for decreasing. So what about negative infinity to negative 2? Remember, you gotta start from the left, right? This is going down. The first one decreasing? Yeah? Okay, so first one's decreasing. So from negative infinity to negative 2. Then look between negative 2 and 1. What is it doing here? Increasing. Okay, so negative 2 to 1. And then what's it doing from 1 to 3? You have a 1 and 3? Yeah. Okay, 1 to 3. Decreasing. And then the last one. 3 to infinity is going up, and that's increasing. Is that the one that you missed? Yeah. Are you okay with it now? Questions? Did I answer your question? Because we're looking at just the x values. That's why they're both not going up to infinity, because you're only talking left and right. If you're on the x-axis and you're going to the left, where are you headed? Yeah. Okay. All right, so the last part, guys, is we're looking at finding the equations of polynomial functions. Here is the great news. You guys have already done this, okay? We did this with quadratics, and we're just going to make it, we're just going to put in a couple more numbers. That's all we're doing, okay? So what you're going to do first off is you want to find the zeros, or find the x-intercepts. Find the x-intercepts of the function. Okay, go and find where the graph crosses through the x-axis. If a graph turns or it bounces at the x-axis, then that's a double root. Okay, you have to write it twice. Now, you want to take each x-intercept, and then you want to change it into a factor. Okay? So, for example, if we had x equals 2, right? Because it went through 2, 0, right? Well, then the factor, remember, you gotta have the parentheses, you gotta have the x inside. It would kind of be like the opposite, right? What's the opposite of positive 2?
X minus 2.
So minus 2, okay? You're basically, or you're making it equal to 0. And then you want to write the equation of the graph in factored form. So you're just going to copy the whole thing over, and you're just going to put an equals y, or y equals with it. Make it equal to y. So y equals, right? And then lastly, you need to check whether your equation needs to be a positive or a negative. So, how do we know? Okay. All right. Remember, your right arm, the right arm of the graph always tells you. If the right arm is going down, okay? Then you need to put a negative in the front. All right, then it's negative. But if your right arm is going up, then you just leave it alone because then it's just positive. Okay, you don't have to do anything to it. Just leave it alone. All right. All right, so let's try this one together. Now, with this graph, okay, what are the zeros here? Where are the x-intercepts? One there, one here, one here. What are they? What numbers?
-1, 0, 2, 0, 4.
X equals -1, and what? X equals what? I'm sorry, what?
2, 0.
And then?
4, 0.
Okay. All right. So I'm going to write them as x equals because if I make them equal to 0, it makes it a little bit easier this way. Or I could go straight into making them factors. So if it's x equals -1, I could add the 1, and then it becomes x plus 1 equals 0. That's what I mean by making it equal to 0. There's your factor, x plus 1. Yeah, it's the opposite, right? If you have x equals a positive 2, well then it's parentheses x minus 2. And then that 4 would be what? X. Yeah. And then what is the equation? Well, y equals, and you know what? I'm going to go and check and see if I need a negative in the front. Which arm am I looking at? Left or right? Right. What is this right arm doing? Going down, so what do I need? Negative. So y equals, put a negative, and then just copy all your factors down. Okay, that's it. That's all you're doing with that one. All right. So let's try our practice. Okay. I want you guys to try the first one. All right, so with this one, I have some zeros. I have 3 zeros here. Yeah, -2, 1, and 6. Change those into factors. So I should have x plus 2, x minus 1, and x minus 6. Yes? Okay? I'm going to say y equals, but I'm going to look at my right arm. This right arm happens to be going up, so I don't need to do anything. Copy everything over. Okay? Yes? All right, good. Let's look at the second one together. So the second one, it looks like I have 1 0 right there and -4. But guys, this is one of those like where it bounces off, right? So that means that we actually have not 1, but double. Good. This is a double root. So technically I have 2, right? All right. So change those into factors. X plus 4 and x plus 4. Do you agree? Okay. Let me look at my right arm before I go to write the equation. My right arm is going down. What does that mean? Negative. Thank you, Kevin. And then you know what? Since they're the same, I could write it as x plus 4 and then put a little square. Okay? Or I could just write it out twice. It doesn't matter. So, for the fun, here comes the fun. Do the last one, please. Try that one. It's a mix of both of them. I think you guys can handle it. Question, why did I write x equals 1 twice? Good, because it bounces. That's where your double root is. Okay, so if I change all of these into factors, absolutely, yes. But Good luck. Do I need to do anything to the y equals? No. And, by the way, it doesn't matter which order I put these parentheses in. No, it doesn't matter. And you know what? I'm going to do what Amner said. Put a little 2. Put a square. Because at x minus 1, I have 2 of them. I can just put a square. Okay? You don't have to. You can just write all of them out too. Okay? All right. So that's it for this packet. Congratulations, guys. A couple things. Next class, you have a short quiz on days 1 and 2 on all this graphing stuff, okay? Make sure you go and review your homework AA and this homework BB. We'll review it before, okay? Go back and review the notes as well. Unit 3 test corrections, again, due January 17, not February 17, like I said last time. I don't know why. I'm like a month ahead, right? Next week, I'll give you guys your Unit 4 tests. They're already graded, but I just have a bunch of people who do need to take them, okay? So if you want to see your grade, I'll put them in the sys, or you guys can see them.